Hello, my name is Darren Thomas. I am the Director of Educational Research Techniques. In this video, we're going to be going over a geometric series and finding the nth term. So let's go ahead and get started. Now, there's something that I noticed that perhaps I was not clear when I talked about an arithmetic series. Basically, this is what's happening. When you are dealing with series, a series is a sum of a sequence. So we know what a sequence is. An arithmetic sequence might be, 1 plus 2 plus 3, and the difference here is, positive 1. And so when you sum these up, it goes from being a sequence, which is a set of numbers, to one number, and that one number is a series. That's something I don't think I was clear with before. And so when we're dealing with a geometric series, what we're looking at now is that we're looking at a collection of numbers that have whose ratio between the two numbers is the same, and when you add up that sequence, you get a series. And that's what's happening. So a series is a summation of a collection of numbers from a sequence. I hope that is clear. And I don't know if I made that clear in the prior videos. So now in this video, we're going to be focusing on how to find the geometric series, over, nth number of terms, if you will. So if I have a sequence where the ratio between two consecutive numbers is the same, and I want to add up a certain number of those, what is that actual answer? And that answer is what we call basically a geometric series. So the equation here for this is going to be as follows. S sub n equals a sub 1 multiplied by the quantity of 1 minus r to the n power. Close that out. All over 1 minus r. And so we know a1, that's your first term, the initial term, if you will. And then we know that n is going to be like whatever number in the sequence, if you will. And then of course the r is our ratio, and we find the r basically by taking a sub 2 over a sub 1. Any two consecutive terms will give us our r, basically our ratio. So again, you could prove this on your own time. That's not the purpose of the class, to do all the theoretical stuff. We want to focus on the actual application of this. So let's say I have the following. And so the first time is going to be a sequence, and then in the second example we'll do it with summation notation, so you can see how they can both lead you to similar answers. So let's say here I have right here. Okay, I'm ready. S sub 20, and for the series of 1,000, then 500, whoa, and then after that down to 250, and then dot because we're not going to write out everything. And we want to figure out, okay, what is the series for this? So all we got to do is we just got to identify our key information here. So let's go ahead and do that. So we know what our equation is right here at the top. So first thing we got to figure out is, what is a1? So we know that 1,000 is a1, and we need to know what is our n here. Well, our n is right here, is 20, and we also need to figure out, well, what is our ratio? Well, if I take a sub 2 over a sub 1, that'll be 500 over 1,000, which is going to equal 1/2. So I have all my information already. You can see that it's not that different. It's just difficult. It's just a matter of getting familiar with setting things up. So my a sub 1 is 1,000 times the quantity of 1 minus r. What is my ratio this time? Is 1 over 20, or excuse me, 1 over 2, raised to the 20th power. That's what I meant to say. And then all this is going to be multiplied by 1 minus 1/2 again. And if you go through all these steps again, you can calculate this on your own time. You will find out that the answer is not exactly 2,000, but very, very close to 2,000. It's like 1,999.999997 or something like that. And so this is our answer. So in other words, if we were to sum up the first 20 numbers of this particular geometric sequence, we would get an answer that is about 2,000. So let's go ahead and do our next one. This time we're using summation notation. So it's a little bit different, but if you look at it closely, it's not that shocking. So we got k is going to start at 1, stop at 8, and we're going to do 3k. And so we need to figure out basically what is the summation of these first 8 terms, because this is my n right here at the top. So let's go ahead and do this one step at a time. Now there's something else I also know as well, is that I also know that my ratio is going to be 3 because I'm multiplying by 3. So my r is 3. I don't have to calculate that. My n, let's get more space here. My n is 8. I don't have to calculate that. But I need to figure out what my a1 is. And so to figure out what my a1 is, I just take this information 3 times k and I plug 1 in for k. So 3 times 1 equals 3. It's not that deep. I took 3 and I plugged in 1 for k. So I know my a sub 1 is going to be 3. So all the information is there now. So now it's just a matter of plugging the stuff in. And so I take my formula again, which is on the previous page here. A sub 1 times the quantity of 1 minus r to the n over 1 minus r. So knowing that information, I plug in a sub 1, which is 3. Inside that, I do 1 minus the ratio, which is also 3, to the 8th power, because the 8th power is my n. And then all this is going to be over 1 minus 3. And so when you solve this, which it takes a little bit of time, I believe the answer is, okay, 9,840. Again, you can calculate this on your own time. And so that is essentially how you deal with that when you're using summation notation. It's just a matter of figuring out where the key information is, depending on the type of information that the problem gives you. So let me go ahead and summarize what we talked about and conclude this video. So in this video, we learned about how to find a geometric series. And so basically we're talking about the sum of a geometric series. And so a geometric series is a summation of a certain subset of a sequence, if you will. And so it's one number, whereas a sequence will be several numbers. And so the formula is right here inside this dark orange box here, and you use this to find that answer. And so what you need to do is you need to figure out what the values are for your different terms inside the actual equation. And again, that's not that difficult. It's often just some basic addition, subtraction, or division, multiplication, or whatever. And so once you have that information, you plug it in and you are able to have success with that. So for our first one, the answer was 2,000. And for our second one, the answer was 9,840. But what was unique about the second one is that we use summation notation, which can be harder or easier depending on how your brain works. But in terms of it being easier, a lot of the information is given to you automatically. And all you got to do is just plug it into the actual equation. So my name is Darren Thomas. I am the Director of Educational Research Techniques. Thank you for watching, and take care.